is lesson 5.4, complex numbers. So we're going to introduce another set of numbers today. I'm going to kind of take you back to maybe pre-algebra or so. Whenever you first started doing square roots, your teacher would put something like this on the board and say, what number would work for x? And you would say, x could be 2 or x could be negative 2. Then the teacher wrote this on the board. And people would say, well, it could be negative 2. But then the teacher would say, no, negative 2 times negative 2 is positive 4. So then you decided, well, it could be 2 and negative 2, but these two numbers have to be the same to get it to be a square. So in this case, you would come up with the conclusion that there's no answer here. So you would want to say solution, but the teacher made you write this, no real solutions. And the reason you wrote no real solutions instead of no solutions is because there is a solution for this one. It just happens to not be in the real number system. It happens to be an imaginary number. So in this unit, you're going to learn the imaginary number system, and it's going to be useful when we start graphing quadratics. So today I can't tell you a lot of application, but we'll use it when we graph quadratics. The other place that I've seen this is with electronics and with building circuits with electricity. You will use imaginary numbers. So there's not a lot of applications, but there are a couple. So in the imaginary system, there's only one unit, and the unit is I. And when I use I will always try to make it a little italicized I, so it's kind of got a little cursive look to it. I is equal to the square root of negative 1. So I is kind of like, it's a number, but the I represents something. Kind of like pi is a Greek letter, but we all know that pi really represents approximately 3.14. So I is kind of like that. It's a letter, but that letter represents the square root of negative 1. So if I equals the square root of negative 1, then I squared actually equals positive. Sorry, I squared equals negative 1, because if you square both sides. So I equals square root negative 1, so I squared equals negative 1. So we're going to use that here. So I'll start off by just simplifying. Well, I botched that up. Simplify the square root of negative 7. So the square root of negative 7 really means this. The square root of negative 1 times the square root of 7. And we just learned that the square root of negative 1 means the same thing as I. So I can substitute I where I see the square root of negative 1. The square root of 7 doesn't simplify, so my answer would be I square roots of 7. Now, if you'll notice, there's actually kind of a little shortcut we can do here. Anytime we see a negative under the square root, that is always going to turn into I. So when there's a negative number under a square root, I can get rid of the negative sign and put an I in the front. So it's kind of a shortcut, but it's really understanding that the square root of negative 1 is I. Let's do another one. Square root negative 16. So I'm not going to break this apart because we already know that anytime there's a negative under the radical, it means that I can put an I on the outside of the radical. So I square roots of 16. And 16 actually has a square root. The square root of 16 is 4. So it's I times 4, but just like if I had 2x, I would not write x2. I would always write the 2 in the front and the x next. So if I'm writing the number 4i, the 4 needs to come in the front and then the I second. All right, let's try this one. Square root negative 18. Well, the first thing I know is if it's a negative under the radical, it's going to be an I on the outside of the radical. And then 18 goes to 2 times 9. And the square root of 9 is 3, so the 3 is going to go out front with the I. So my answer would be 3i square root 2. So that's simplifying. Let's talk about multiplying I. Multiplying imaginaries. I'm sorry, I'm sloppy. I-M-A-G-I-N-A-R-Y. Multiplying imaginary numbers. So let's start with this one. 2i times 3i. So when you multiply, it's kind of like just treating this like it was an x. So for instance, if I had 2x times 3x, I would say that's 6x squared. So same thing works with I. 2i times 3i is 6i squared. But in this particular case, I squared actually represents something. So if you go back up in your notes, I squared is the same thing as -1. So I'm going to substitute a -1 where I had the I squared. So I have 6 times -1, which is -6. Let's do another one. 4i times 5. 4i times 5 is just 20i. Since I don't have an I squared, nothing changes. This would be the answer. Let's do this one. I times I. It'd be kind of like having x times x. When you have I times I, it's I squared. But I squared represents -1. So the answer in this case would just be -1. Let's do one more. Once you try this one, pause the video and then see how you did. So if you tried this one, 2i times 5i is 10i squared. And we know that when we have I squared, this becomes -1. So I have 10 times -1, which is -10. You might already kind of seen a shortcut. When you have I squared, it just changes the sign of the number that was there.